Welcome to How to Solve College Board AP Chemistry Free Response 1993, Number 8, Parts A through D. Let's look at the question. The reaction represented below is spontaneous at 25 degrees Celsius. Assume that all reactants and products are in their standard states. 2C4H10 gas plus 13O2 gas yields 8CO2 gas plus 10 H2O liquid. Predict the sign of delta S for the reaction and justify your answer. Part B. What is the sign of delta G for the reaction? How would the sign and magnitude of delta G be affected by an increase in temperature of 50 degrees Celsius? Explain your answer. Part C. What must be the sign of delta H for the reaction at 25 degrees Celsius? How does the total bond energy of the reactants compare to that of the products? And Part D. When the reactants are placed together in a container, no change is observed even though the reaction is known to be spontaneous. Explain this observation with activation energy, E-act. For this question, some prior knowledge is needed. First off, the Gibbs free energy equation. Delta G is equal to delta H minus T delta S. Secondly, thermodynamically favored or spontaneous reactions have a negative delta G value. Third, therefore, favored reactions typically have negative delta H values and positive delta S values. And finally, favored reactions do not necessarily happen quickly. Let's look back at Part A. Predict the sign of delta S for the reaction and justify your answer. Delta S is a measure of entropy or disorder in a reaction. An easy way to find the value of delta S is to look at the moles of gas reacted to the moles of gas produced. If more moles of gas are reacted than are produced, there is a negative delta S value, as order is increasing. If more moles of gas are produced than are reacted, the delta S value is positive, as disorder is increasing. For this reaction, 15 moles of gas are reacted and only 8 moles of gas are produced, meaning that for Part A, the delta S value is negative as more moles of gas are reacted than are produced. Less disorder occurs throughout the reaction. Let's go to Part B. What is the sign of delta G for the reaction? How would the sign and magnitude of delta G be affected by an increase in temperature of 50 degrees Celsius? For this question, let's go back to our prior knowledge. We know that the Gibbs free energy equation is delta G equals delta H minus T delta S, and that thermodynamically favored or spontaneous reactions have a negative delta G value. This means that for the first part of Part B, the delta G value is negative, as the reaction is spontaneous. Now for the second part. How would the sign and magnitude of delta G be affected by an increase in temperature of 50 degrees Celsius? Looking at the equation, we know that delta S is negative, and delta G must be negative. So delta G is equal to delta H minus T delta S. If we increase the temperature to 50 degrees Celsius, then that means that delta H and delta S are not changing. This means that since delta S is negative, negative T delta S becomes a positive value. So delta G becomes less negative as the temperature increases. So the answer for the second part of Part B is delta G would become less negative at 50 degrees Celsius as delta S is negative, causing Gibbs free energy equation to go from delta G equals delta H minus T delta S to delta G equals delta H minus T negative delta S, and the negatives cancel. Part C. What must be the sign of delta H for the reaction at 25 degrees Celsius? How does the total bond energy of the reactants compare to that of the products? Going back to our prior knowledge, we know that the reaction is spontaneous, and therefore, favored reactions typically have a negative delta H value and a positive delta S value. Since we know the delta S value is negative, this means that the delta H value must be negative. So for part C, delta H is negative at 25 degrees Celsius as the reaction is spontaneous. And since negative T delta S yields a positive value, delta H must be negative to reverse that value. Now for the second part. How does the total bond energy of the reactants compare to that of the products? We know, since the delta H value is negative, that the bond energy of the reactants is lower than the products, as the equation for delta H is E of reactants minus E products. So the energy of the reactants must be smaller than the energy of the products. Finally, let's go to part D. When the reactants are placed together in a container, no change is observed even though the reaction is known to be spontaneous. Explain this observation with activation energy, E act. For part D, the reaction has a high activation energy, so the process does not proceed quickly. As drawing from our prior knowledge, we know that just because a reaction is spontaneous does not mean that it happens quickly. This means that the reaction has a high activation energy that is not being met in the conditions of the experiment. That is it for 1993 parts A through D. Thank you.